Do we need to use this one? Okay. I'm not sure whether we're supposed to start, but there is no moderator here. And so it's time, I think, to start. So we will just do exactly that. So first of all, welcome to the first afternoon session. This is about the Web UI chapter, the Advanced Web-Based User Interface chapter of FIWARE. And we will do the presentation together. My name is Philipp Slusalek. I'm a professor for computer graphics at Saarland University in Germany and scientific director at the German Research Center for Artificial Intelligence, where I lead the area of agents and simulated reality. I'll give a quick overview and introduction, and then Thorsten Spieldenner will take over, who is the architect of the Web UI chapter. And he will tell you much more about the details, the different UIs, the different GEs, and how they work together and what you can do with them. So to get started, we have these different chapters in FIWARE. You've probably know quite a bit about the general setup of FIWARE. And in the following, we'll focus on the advanced web-based user interface chapter. In terms of the details or the architecture of this chapter, the objective is to significantly improve the user experience in FIWARE. Obviously, we all know that user interfaces today are, to a large part, in particular if you talk about web-based or service-based developments, user interfaces are in many cases actually implemented through the web browser in HTML5 and things like that. And there is a strong continued development on that side, but that is mostly focused on 2D user interfaces as we all know them. What we're focusing on is building on top of that, extending that. So in the web, we already have video. Of course, we have text in various formats. We have images. We have audio. But we didn't have really interactive 3D graphics. And this is what we're focusing on here, really integrating interactive 3D graphics directly in the web browser and also allowing this to be shared so many people are distributed across the world connecting to a shared 3D experience. And that 3D experience is really not a separate entity, but it is part also of a 2D. So it could be a 2D, 3D experience, and the 2D part and the 3D part are part of the same web document, of the same web page, using exactly the same web technology. Actually, we implemented all of the stuff you will see today in JavaScript without any extensions or anything. All of the technology for doing this is in current browsers already. And Thorsten will go into a lot more detail here. In addition to the core functionality, there's a number of additional generic enablers in this chapter. Well, maybe quickly go through that. So we have the, where's my pointer here? Here it is. So we have the core of the server core of the GEs, which is essentially synchronizing different 3D experiences. We have the client core, which is really the part that runs in your browser and enables all of the functionality. And then on top of that, we have client-oriented generic enablers, virtual characters, interface designer, and in particular augmented reality, and we'll show some examples of that later. And then on the server side, we have some supporting generic enablers for displaying geographic information data as well as point of interest data. And you will learn more about that later on. We also have rendering on the server-side rendering as part of this architecture. And so in the following, we will talk about the core technology here on the server and the client side, and we'll give you a little bit of insight about some of the additional GEs that we have developed in this area. And with that, I hand over to Torsten, who will show you all the details and some of the demos.
Okay, so thank you for this introduction. And from here, I will dive directly into the details of our chapter. As Philip already pointed out when talking about user experience in the web nowadays, this covers already a wide range of different media types. There is not only text anymore on the web pages as it was in the early days, but there is also multimedia content like videos, there is audio, there are interactive elements, and moreover the web pages are no longer static, but a wide range of the content that is available on the web is nowadays created by users. So sharing content and publishing content that is user-made is also a big part of nowadays web experience. As a result, many types of standalone applications which were formerly implemented as applications that ran on your PC have now moved to the web. So popular examples are, for example, email clients, which are now available as webmail, but also collaborative text processing, which you also often use here in terms of Google Docs, for example, but also image and video editing tools, which are integrated in platforms like YouTube, but also Facebook or others. And dimension, which is a bit underrepresented, maybe not underrepresented, but not as easy to realize nowadays, is 3D visualization, even though it provides a compelling set of use cases also to extend the experience even further. So applications like smart city visualizations, interactive smart city applications, visualization of IoT data, also visualizations in terms of robotics, also talking maybe about prototyping of new building parts. All this can be enhanced by 3D graphics, obviously. And actually 3D graphics in browsers are already available for quite a while. So the goal is not to create 3D in the browser for the first time. This came with WebGL some years ago and has become so popular in the meantime that also recent game engines, for example, target the web browsers as application platform or as target front end for client applications. However, creating these 3D applications with the given tools, be it directly against WebGL or using the game engines, this requires quite a deeper knowledge and also some experience in 3D application programming. Especially if you implement directly against WebGL, it's very close to the GL programming. But also if you use these provided game engines and the deploy mechanism there, you will have a steep learning curve and also some considerable effort, even for the smallest applications. Now, what we're doing in the Web UI chapter is an approach to solve this and make 3D graphics more accessible to designers and people who are more familiar with web design, is to describe the 3D scenes and 3D applications in a declarative manner directly in the website. So the idea is that the 3D UI XML 3D generic enabler, which provides these capabilities, extends directly the HTML5 node set, so it introduces new nodes to describe 3D scenes directly within the web page with the common tools that are familiar to web designers. And this includes new nodes to describe 3D models, but also the materials that are attached to the models, the respective textures, lighting of the scene. And the nice thing is that the way it is implemented, namely as JavaScript library, it runs directly in the browser, so there is no plugin needed in order to display these 3D scenes. But every modern common web browser is able to display these declarative described scenes. And moreover, by embedding it directly into the web page, we can also use the capabilities of existing services, especially those from FIWARE, which provide interfaces to web applications to directly link these services and the data provided by the services to these 3D scenes. In the following, I will give a short insight in how this can be done. First, here is a very short example of how such a 3D scene in the browser looks like. So for those of you familiar with web design, it's basically nothing more than a standard web page. The new nodes can be found here. It's basically the XML 3D node, which encapsulates the whole XML 3D scene. And everything which is included within these tags now describes our 3D scene. Here, for example, nodes to define transformations. You have grouping nodes, which allow to group different models and apply, for example, a common transformation to them. And you can, I lost my mouse pointer. Also reference external data. For example, this cube.json will then contain vertex and normal data that describes a cube 3D model. And the nice thing is that this is not entirely in format particular to XML 3D, but it supports various formats. You can link JSON representation of 3D models, XML representations, but also GLTF or Collada models. There are a few exporters which allow also to export to the XML 3D format. So if you have some model existing in Blender, you can run an exporter over it and integrate the model in your web page. For more complex scenes, XML 3D provides an asset mechanism. This means even quite complex structured models can be hidden behind an externally referenced web page. You can instantiate them with one single tag, which resembles very much integrating an image into a website. You can make quite complex definitions of your assets in an external file, and then by one single tag also instantiate this model within your scene. You see two examples here of different use cases. Here, for example, this might be how a multi-user application looks like. In this case, every user is an instance of such a robot model, or also in collaborative 3D editing tools, you would be placing instances of predefined 3D models directly into your scene. Now, so far for static scenes, in order to bring interaction to it, there are different interfaces to modify the scene during runtime. So the most convenient way is that there are directly HTML events registered on the XML 3D nodes. So whether you have a model or an asset or a mesh in your scene, you can register on mouse over and on click events, as you would do it also for images or paragraphs in your web page, and by this directly profit from the interfaces that HTML gives you. There's a JavaScript API for more complex scripting, and this can also be used to create or modify new nodes in the website's DOM tree. By this, extend your scene, modify your scene, or also build a connection between the 2D content of the web page or the 3D content. And a benefit from that these XML 3D scenes are basically part of the website and its DOM is that we can use established frameworks like jQuery or Backbone.js or others to query the scene or to modify it. And I have a very simple example here. So assuming we have a cube already existing somewhere, the one I showed before that has an ID that is called cube, we can use jQuery to find this cube in the scene, and by just changing the attributes of this node, we can apply new transformations, but also new shading information. And in the same way, we can also create new elements and just add them to the DOM. So this is very much similar to how you would also create 2D elements or static elements in existing web pages. For more complex computations, we have a tool called XFlow. The name comes from the fact that it's basically a data flow description that is directly integrated in the XML 3D implementation that we provide. So data flow description language means we have a set of input parameters that we can define. These can, for example, point to services that are deployed in FIWARE, context broker, for example. And then based on this input data, a set of operators is run, and the result of these operators is piped back in our scene, and by this changes our scene dynamically. The nice thing is that the XFlow data flows can be computed on GPU, so they can be computed efficiently, and for this are highly suitable for complex tasks like character animation, which performs some skinning animation on the models, but we can also map input data from IoT sources, for example, to our scene. By this, apply vertex transformations or shader transformations, and, for example, change the height of these bars, assuming that they maybe represent pressure or temperature in a 3D map. and we can adapt the height and the color and maybe also the shape of these models according to external input data. And by this, the whole framework XML3D with Xflow and the JavaScript interface provides a compelling tool to add information visualization to our 3D scenes. Now, so far we've seen the version of XML3D that we are providing in FIWARE currently. The future development, which we are currently working on, targets at exploiting the capabilities of web components, which is a new concept that is implemented in the latest browser versions, becoming more and more accepted. And this allows to, on top of these generic grouping and mesh and light nodes, also define custom nodes that encapsulate more complex and user-defined concepts. So we have seen these robots in this multi-user scenario before. So we could, for example, also define nodes which says we have an XML3D robot here, and the node provides us an interface to the values that we need to modify, for example, animation or shading of the robot. A small example is down here. So this is how, for example, a teapot could be described as a web component. And instead of instantiating a teapot mesh and doing the transformation manually, we could just define that this node knows about its scale and its color, and by this modify the model accordingly by just adding this node to the DOM tree. So to sum up the 3D UI generic enabler so far, we've seen that it allows us to create interactive 3D graphics in web applications by simply extending the HTML5 web page in which the 3D application is running. And by using the web or the DOM interface as well as JavaScript and Xflow, we have plenty of options to also link the 3D graphics that we create in the static scene dynamically to external services and also application-specific data, which may come from a use case in a FIWARE scenario. Now, one generic enabler that does this, for example, already is the augmented reality generic enabler. This one uses 3D UI XML3D and the connected Xflow capabilities in order to implement marker feature and marker tracking operators directly in XML3D. And by this, we can, for example, detect this kind of markers, which most of you may have seen before, and by this position the 3D objects also in our scene, or change the orientation or animation of the objects. And in one of the FIWARE hackathons, this one was actually also used to create a nice web game which spawned 3D spaceships from street signs. And by this, you could walk a city and collect your high score on different street signs of the city. Another use case from the visualization field, which is also encapsulated in a generic enabler in the Web UI chapter, is the GIS data provider. This one provides elevation datasets from different regions in the world in different formats. You can query the provider using a REST call. You specify your geolocation in longitude or latitude. You specify the format. And as a result, you get an XML3D chunk, an XML3D tile, which directly visualizes the 3D map at this area that you specified. So basically, as a resource that you link to your 3D scene, you can specify this location on the GIS data provider, you query to the GIS data provider, and by this assemble your 3D map from the data that is provided there. And with an additional generic enabler from our chapter, the PUI data provider, you can run the same query, the same longitude, latitude-based location query on the PUI data provider, and in addition to the 3D visualization of the map, you will be provided with all the points of interest in this region. And attached to these points of interest, you also can specify a 3D representation of the object, either as XML3D resource or as raw mesh data, and have your PUI also visualized in 3D directly on your 3D map. So far, these have been single user applications, so we've seen how to create 3D maps. We have seen how a single user in the web browser can inspect the 3D scenes and interact with the 3D scenes. What is missing at this point is the question, how can we share a 3D scene among multiple users? So how can I not only interact with the 3D scene as such, but also with other users who are part of the same 3D scene? There are plenty of use cases for this scenario. Very popular, possibly the gaming scenario, but also social platforms in which members of the social platforms are represented as 3D avatar, but also training applications with different roles in training scenarios, and also collaborative work scenarios, CAD work, for example, or 3D design. And the solution for this in our chapter is what Philip introduced earlier as the server core of the Web UI chapter. And this is basically provided by the synchronization generic enabler. And I will in particular highlight the implementation 5s here because it's the one with the latest release in the chapter. The role of it is to, or let's maybe start like this. If you want to provide a multi-user environment, the most common requirements are that there needs to be a consistent world state that is to be stored somewhere in the network, either on the different nodes connecting to the application or on a server node that is running somewhere in the cloud. And as soon as the clients connect to this world, they get the recent world state, which is depicted here, so they have an immediate insight into how the world currently looks like. And as soon as some node changes the state of the world, the state needs to be, of course, transferred to all connected clients in order to end up with a consistent world state in all connected applications. And very often, especially in gaming, but not only in gaming, but also in these social platforms maybe, there's a, let's say, soft real-time requirement that as soon as one node changes the status of the world, it is immediately transferred to the other clients, so they always have the same state of the world. Now, the synchronization generic enabler, in order to be as generic as possible and easily adaptable to different application use cases, is a very lightweight server implementation in the sense that it tries to make no assumption about the actual application data from the beginning, but rather provides an extendable component system, which I will show a bit later. The data in the server can be queried either by a REST HTTP request via a scene API, and there's also a WebSocket communication for real-time synchronization to connected clients. And the main target clients are web browsers, in particular, of course, also the 3D UI ones we have seen a bit earlier. Now, within the, maybe to get the whole image of what synchronization then does in the role of FIWARE, is that we have a number of scalable backend data providers. We have the context broker. In the last session, we have seen the IoT broker. We have seen different IoT gateways to connect to. And these provide access to data for large-scale complex applications. For example, city visualizations, which we have also addressed shortly a bit before in the 3D UI city. And now what synchronization does, it allows to offload the computation of these applications to some node in the network and not have the browser-based clients do all the work, but we pre-compute the world state. We provide it in a model, in a data model that can be interpreted by the 3D UI immediately, but also by other visualization clients. We can run simulations on the data and send data based on simulation to the clients instead of the raw data. We can filter the data. We can do all this before we send it back to the clients. And by this, we consider, and this is actually how we used it quite often, this synchronization generic enabler in our applications, as a bridge between the data that comes from outside or that comes from somewhere within FIWARE, a bridge between this and then on the other side, the web UI front ends and the clients. So the very high level architecture looks like this. I've mentioned it shortly before already. We have the server, which provides the RESTful scene API, which is not necessarily meant to be compatible to the real-time requirement. It can be, but doesn't need to be, but is more for external access and one-time modifications like external editor applications or one-time queries to just get the current world state. And then on the other end, we have the real-time sync protocol, which is based on WebSocket, which always immediately transfers new world states to the client. Yeah, and of course this HTTP interface is basically meant for CRUD operations to modify the internal scene model, adding new objects, modifying existing objects, or asking for the state of objects which are already there. Now, the data model we are employing is an entity component attribute model, which of course also maps quite nicely to what the context broker provides us. We have also seen examples of this in previous talks. So the idea is that the objects we have in the world are basically just empty data containers from the beginning, and the actual meaning and the data that these objects carry are defined in the terms of components. For example, if some object in our world should have some 3D location in the world, we would attach a location component, and this one carries the data of the 3D location. The nice thing is that these components can be defined and assigned during runtime, so this means we don't need to recompile this server when we want to attach a new application, but we can just introduce new data structures while the server is running. We can deploy a new instance of the server to the FIWARE lab, for example, without changing anything to the code or needing anything to compile, and just introduce new components while the instance is running. This entity component attribute model, as I said, maps quite nicely already to what we get from the data providers. Here's an example of how a POI could look like in the synchronization representation. This would now be an entity which is identified by some universal identifier, and then we have different components which describe the capabilities and the role in the world. So in this case, it carries a component to describe its location in latitude and longitude, so this one would be suitable for geovisualization. It also carries information about how we would visualize this entity using the XML 3D generic enabler here. So we have here an asset that would be rendered for this one, and also different configurations of which input data we would map to which output parameter. And FIWARE's, the synchronization generic enabler implementation, also supports NGSI v2 formatted messages, so we can directly exchange messages, for example, with the context broker using the NGSI v2 format. This is how data maps from backend to server, and now the mapping from server to front end is equally simple. So we can basically directly fetch our components that we define on server side and map them to 3D UI DOM nodes in a model view manner. So here's an example of how this might look like. We have an entity with a mesh, transform, and material component. So this means this entity has some transform in the 3D world. It carries information of how the 3D representation of the entity should look like, and also some material. And these would be the respective nodes that we create in the XML 3D generic enabler. And we are not limited to this representation if for some reason we changed the way how we describe transformations and meshes or switch to a different 3D render framework. We could also map it to a different style of nodes. So on the above image shows a bit of how our example application does all this. We have the model layer, which retrieves the entity collection from the server. We have the controller layer, which basically arranges the entities in the client representation and also checks for the externally referenced resources. So if we define a mesh here, this part of the application knows where to look for this mesh. And here we see a few of the applications. We have also some visualization of factory modules. So in this case, we got information about pressure and velocity of certain parts of this module before actually implementing it. This one builds on this one, so it basically uses the same world, but adds information that can be used by AI agents, which then interact with the scene. So this adds the factor of human workers and allows to estimate how efficient this factory might be handled by human workers. And the last one is a dual reality application in which we had a factory setting with different kinds of robots, and these interacted with the human workers, and we could not only see what the on-site situation was in the 3D visualization, but we could also use the 3D visualization to steer the robots in the real world. And going from these multi-user scenarios to 3D map multi-user scenarios is then a simple task, because all we need is a component that describes the role of one entity in the world as a geopatch, We use the capabilities of the GIS and POI data provider that we have seen earlier in order to create also entities from these query responses on server side, which are then in turn rendered in our 3D visualization on client side. And in this example application here, which was shown on the ACFI conference, I think, we also used some Xflow operators to extrude buildings from OpenStreetMap data. So to sum up the talk, we've seen how 3D graphics can enhance the experience of existing web applications, which already bring a wide range of different multimedia types. But by building heavily on the existing HTML5, the 3D UI enabler makes the creation of these 3D web apps also accessible for web designers and people not being too familiar with 3D graphics implementation. And not only static 3D scenes are possible, but also interaction can be added quite easily by adding, by making use of the standard HTML events. Apart from this, we can link our 3D applications to arbitrary data sources. On the one hand, using these model view patterns I have quickly highlighted with the synchronization generic enablers, but also with the capabilities of Xflow and JavaScript, we can use established HTML frameworks to modify our scene after it was deployed to the browser. And we have seen how to create examples of the domain of geo-visualization, and also how we can serve multiple clients in a shared environment with the synchronization generic enabler. Which uses a generic data model, this entity component attribute model, which is easily mappable to both backend data, so we can connect to different data sources, but also to the 3D UI scene graph, which means we can directly bridge from the data source to the client using the synchronization generic enabler. And by this, synchronization provides the bridge between FIWARE data backends and multi-user 3D front-end applications. So this concludes the talk. I would now show a few demos, demoing mostly the 3D UI generic enabler, and afterwards I would say we move to the questions. So the first demo is quite simple. So what we see here is the 3D Rubik's Cube. This is rendered using the 3D UI XML 3D generic enabler. So this whole cube is a DOM object, basically, an object that lives in the web page. Same for all the surfaces. And you see now interacting with the scene is as easy as registering, for example, an on-mouse over event on the surfaces. This is what is done here. It's just part of the web page, so this is possible, and we just change the shading of this. We can also interact with the scene and rotate it, but we can also use other events like on-click to just interact with the cube, select one of these parts of the cube, and also then play this Rubik's Cube game, which is, I think, quite well known. I have also talked about using Xflow for skinning, so this actually works. Here's an example. These are 3D meshes which are provided with a skeleton, and this skeletal animation is then computed using a skinning operator provided by Xflow that can just be applied to these 3D models. And as a last example from the domain of construction, maybe. So this, Philip, correct me if I remember it wrongly, was in cooperation with the UCL London University of and the idea here was that during the rework of the King's Cross station in London, there's also a 3D model which allows to inspect the new station before it is actually built. And this actually shows that we can not only create these toy examples, but that the generic enabler is actually also capable of displaying really large scenes of how many million triangles were these?
Can't remember. It's several million polygons here. Maybe you can fly into the building.
Yeah. So it's not just the roof, and you see it's also quite detailed in the inside.
People who've been to King's Cross Station, this is pretty much what it looks like today.
Okay, and this concludes the presentation at this point. And we're open for questions.
Yeah. execution on current CPUs, so they have these SIMD extensions, SSE and AVX. Intel and others and the browser vendors are currently teaming up, or actually it's in the beta versions of the browsers already, to be able to use these SIMD instructions. And we're getting a speed up factor for some of the computations of more than a factor of 3. In JavaScript, we write your code still in JavaScript, but we optimize it in our engine. That is not in the current version of what we deliver, but that we plan to make that part of FIWARE in probably within the next year. I can't make any promises yet, but it's something that works internally already, but still needs some more work, and it's not in the browsers yet, so we have to wait until Firefox and Google, Mozilla and Google make that available. But you see, oh, actually, can you show the augmented reality?
Right.
Because that actually goes into your direction, I think.
Right, this is here somewhere. I forgot this one. Flying teapot.
By the way, this webpage here is off of our XML3D webpage. So you can actually just go there and play it in your browser as well. You need a WebGL enabled browser. There's still a few out there that are not WebGL enabled. Sometimes some older laptops, the hardware is not up to the. So what you see here is actually there's a video running in the background, and the video contains some of these markers here. And the application logic says, okay, on top of that marker we have a teapot jumping up and down. And so the orientation of the marker determines in which direction the teapot jumps. And this is, so the teapot is not in the video, right? The video does not contain the teapot. We just show the video here, and then online in real time we detect the marker. So this is like your depth computation. So we do marker detection on the running video in the client in JavaScript. And then once we detect the orientation, we render the teapot on top of that relative to the 3D position of that marker, which we reconstruct from the video. And just to prove that this is not in the video, we can actually switch to the camera. And so this is Torsten. And if the lighting conditions are just right, you will see that there is a virtual teapot jumping up and down on top of what Torsten is just showing there. And you can also maybe show both.
Let's try. This one was a bit stubborn before.
Maybe move it a little bit further away from the camera.
It's a bit broken on the edge. Maybe this is the problem.
Right. So maybe we need a little bit better lighting for that. So this is not a production demo, of course, but it kind of shows what can be done with the entire framework, including augmented reality. Actually, to add to that, there is, so I co-organized with the W3C. W3C is a World Wide Web consortium which standardizes all of the HTML stuff. And there was a workshop about 2 or 3 months ago in San Jose about WebVR. WebVR is essentially technology that the browser vendors are developing internally right now for attaching the Oculus Rift, Vive, and all of the other VR headsets directly to the browser. And so the idea is someone sends you a link, you click on the link, the browser opens it, you're right in the 3D scene automatically with your VR headset, maybe in the future even with augmented reality headsets. And that's something, so that was like a kickoff event for this development. This is being driven now by W3C on the one hand side, and Kronos, which does all of the 3D optimizations, 3D standardizations, I need to say, on the hardware and low-level software side. So there will be a lot of development in this direction also in the next year, or maybe a little bit longer. It depends how long that will take. So I think this is very, very exciting technology. We can directly drive that. So in-house, we have already a prototype implementation of WebVR for some of the beta versions, 90 versions of the browsers that already contain an early implementation of that. So this already works here There's lots of examples and other stuff on our webpage if you want to see more. But there's more questions. Yes.
I believe it won't be a problem to add also simulation algorithms in this procedure. For example, let's say that I can see how the suspension system of a modern car works.
Absolutely.
And change the terrain and maybe take actual terrain and see how it works, but after computation of simulation algorithm.
Yes, and that's exactly what we do in a number of projects that we can't show here because they're usually industry projects where we have some simulation code somewhere, we package that as a service, and then we get updates on the model and display that in the browser, and we can also control the simulation from within the browser. So one of the big projects we're currently doing is kind of doing synthetic data generation for learning for autonomous cars, for instance. Really interesting application. That of course goes beyond what we show here, but yeah, I think this is a really nice use case or scenario of linking simulation code of various, I mean, this could be agent-based, large-scale city simulation, could be like a very mechanical simulation, could be lots of other stuff. And the really nice part is, right here you're in the browser, you can very easily link to these services once you have a suitable service interface. And Torsten kind of showed how easy it is. You just put a link there as long as it provides the data in some meaningful JSON or whatever format. It's very easy to link that to the 3D model.
I believe that this could be very useful for education also.
Yes, we're not doing any educational projects, but we use it for training in industrial scenarios, which is kind of an educational scenario as well. We're not doing anything in schools yet, but maybe others want to pick that up. Yeah.
Yes, thank you.
Any other questions? Okay, great. Thank you very much. Torsten and myself will be here also until tomorrow evening, so if there's any more things, just approach us in the breaks. Thank you.
Sorry. We will make a quick introduction in the big data technologies, Hadoop and Storm. Okay, we will see how to deal with storing and computing problems. Okay, regarding these technologies, and finally we will see an introduction about how these technologies has been used and deployed into FIWARE Lab. You know, FIWARE Lab is a place where you can play with the technology. Okay. So, well, let's start. First of all, as I've told you, okay, let's try to define what is big data and how much data is there, because it is not very clear what is about this concept. So, I always like to start using this kind of example, because well, if I ask you about all these books, okay, I can ask you if you think, well, task of reading all this book is a big data problem or not, no? And as we will see, well, not a big data problem if we compare this other problem. Well, in both cases, we have two main issues or problems. First of all is the storage, okay? The storage problem regarding this all this kind of information. Well, if you compare the first example and this one, well, you will agree with me that well, in this case, we have a real big data problem because we need the specialized services of a library, of a public library, in order to store all this kind of information. And not only regarding the storage problem, but the computing problem. Well, the previous example, well, with enough time and a lot of patience, we could read all the books that we have in our house. But in this case, you will agree with me that it's impossible to read all the information that is stored in this specialized service that is called a library. So, as you can see, the concept of big data is not just is not a matter of thresholds. You can say, well, I have 3 terabytes of data, and well, I can consider this as a big data problem. It would not be a big data problem if your infrastructure is able to deal with such a data, both in terms of storage and computing. But if you are dealing with, say, again, 3 terabytes of data, and your infrastructure is not able to store such a data, or you are able to store such a data, but you are not able to process it in an acceptable period of time, then you are facing a real big data problem. So, as you can see, there is not a clear threshold or frontier through the one you can say, okay, I'm dealing with a big data problem or not. So, well, once we have seen that the 2 main problems regarding big data is the storage and the computing, okay, let's see how much data is there. And I always like to show you this publication, this news, okay, regarding, well, I think this is very, very funny because, well, I made a quick research and I found that in the Wire magazine, okay, in 2007, okay, they say that we were in the petabyte age, okay, more isn't just more, but then I found in the same publication several years after, specifically 2012, okay, they said that no more in the petabyte age, but we were in the exabyte revolution. And then I found that Cisco said that we were in the zettabyte area. And finally, I found this other publication that said that there is so much data out there that we are running out of words to describe it. And it is real, okay? These are, well, 3 graphics trying to depict the data growing forecast, okay? About, this is from Cisco, okay? You can find there the complete analysis of not only data growing, but devices growing, traffic and devices growing by sector, and so on. But well, I have extracted 3 graphics that I think that will illustrate very well what I want to say. Cisco estimates that in 2020, okay, both the people and their devices and the Internet of Things and many other sources of data, okay, will be generating approximately 200 exabytes per month. Okay, if you wonder what is an exabyte is a 1 followed by 18 zeros. Okay, so you can see here the trend from this year to the future. Okay. If we go to the number of devices that will be connected to the internet, okay, you can see here again that this number will grow from our year to the 2020 year. Okay, I've cut here the explanation of what these colors mean, but this last color is about machine-to-machine devices. So you can see that, more or less 50% of the devices on the future will be related to machine-to-machine and Internet of Things stuff. Okay? There is another very interesting graphic talking about the number of IPv6 enabled devices in the future, and there is another graphic that is growing up a lot of in the time. And finally, you have here a summary on which kind of machine-to-machine devices will be contributing to this growing of data. There are a lot of sectors, okay, energy, agri-food, manufacturing, retail. So once we have seen more or less what is big data and how much data is there, and most important, how much data will be there, okay, in the internet, let's see how to deal with this very large amount of data that is coming. Well, typically there are two approaches, okay? Probably you have heard about them, okay? The batch and stream processing. And I will talk as well about the Lambda architecture, that you'll see that some kind of combination of batch and stream processing. So what means batch processing? Well, batch processing is just about collecting a lot of data for a long time, okay? You don't care about time because, well, your only purpose is just to collect data, But when, to some extent, you may want to analyze that data. Well, again, the same that you have spent a lot of time accumulating data, you have not a problem if after analyzing that data you have spent several hours or even days analyzing that data. Okay? So the most important thing regarding batch processing is that particularly time is not a problem. Okay. One thing that is also very interesting from batch processing is that the analysis can be reproduced, because the data you are going to analyze is stored. Okay, it is saved somewhere else. We will see typically where the data is stored. Okay, regarding big data platforms. Okay, but as I'm telling you, because the data is stored somewhere, okay, you can reproduce the analysis on time, or even perform the same analysis using the current data and the future data that you will append to the current data. On the other hand, the stream processing is just about not storing the data, but processing it on the fly. Okay? In this case, I'm telling you, the data is not stored anywhere. And in this case, the time is important. That's why you are not storing the data. Because in this case, what you are going to try to do is just to analyze the data on the fly in near real time, okay? And, the results of the analysis are expected to be obtained in near real time as well. So, because the data is not stored, once you analyze or don't analyze it, say lost, okay, it's lost from the point of view of the analysis system. So the analysis cannot be reproduced because the data can say it has been lost. Okay. So these are the most important approaches when dealing with data. Okay. Batch processing and stream processing. There is a third approach that is called Lambda architecture. Okay. There is not, again, a clear or definitive definition of what is a Lambda architecture, but there are many Lambda architectures. Even if you go to this URL, okay, you will see there several examples of Lambda architecture, several examples of big data analyzing system or platforms that are Lambda architecture compliant, but well, all of them are very different one each other. we can say that Lambda architecture combine the best of both approaches, batch and stream processing. The idea behind the Lambda architecture is that, well, you may spend all the time, you may want accumulating and collecting data. And once you have, let's say, an acceptable time frame of accumulation, you analyze that data, you take the time you may need to analyze this data, and you create some insights that are stored in some quick access database, such as MySQL or MongoDB or whatever you want. And the problem is that while you are storing or you are collecting and analyzing this data, what happened with for example, with a query service that you provide to the users regarding your data? Well, while you are doing that batch processing, okay, batch accumulation and batch processing, you perform real-time processing with the last data you are receiving as well in the streaming analysis part of your system. The idea is that both batch and stream processing create insights that are cached in these quick access databases, and well, queries to your system must combine the short-term insights that the real-time processing has created and the large-term insights that the batch processing has created. Well, so once we have seen what is big data, how to deal with it, we are going to see, well, in some detail how the factor standards in big data industry works. We are going to see the Hadoop reference. We are also the Storm reference for streaming. Well, regarding batching, this DFS stands for Hadoop Distributed File System, okay? And this is where we are going to accumulate and collect all the data that we will analyze in the future. So, continuing with the books and the shelf examples, okay? Just a very simple question. What happens if one shelf is not enough for storing all your books? Well, has a very easy answer. You buy more shelves. Buy more shelves, and well, you put all your books in the shelves in a distributed way. But well, in order to know where you have put, for example, the X-Men books in the shelves, what you create is just a kind of piece of paper where you put, okay, X-Men are in the shelf 3 and 4, in the shelf 3. These are the numbers of the X-Men books that we have put, and these are the other numbers of books that we have put in the shelf 4. And this is something that, well, anyone could imagine. Well, this basic and simple idea is the one that is behind the Hadoop distributed file system. We will see that it works exactly this way. Okay? So, going into more specific details regarding this HDFS, okay? It is based on Google File System, okay? Google just created a paper several years ago, and well, the Hadoop creators got inspired with this Google File System. Okay? The idea behind the main idea behind HDFS is, tell you, okay, is just to have a special, well, it's just to have a cluster of machines that will hold the role of shelves, okay? Where we are going to put the data in a distributed way, okay? This will be the data nodes, okay? And there is a special node that is called the name node that will hand the piece of paper, just having pointers to the places where the real data is stored, okay? This is a very scalable idea because, well, if you are running out of space for storing more data, you just add more data nodes, okay, and the name node get aware about that. Okay? Well, this is a very scalable idea because, well, if you are running out of space for storing more data, you just add more data nodes, okay, and the name node get aware about that. Okay? It is fault tolerant because the data, we will see the data when storing HDFS, okay? When we talk about storing big data in HDFS, we are talking about storing large data files, let's say of a lot of gigabytes or even terabytes. So it could be the case that a single server could not hold this file. So the file is split into many blocks, and these blocks are distributed into all the data nodes of the cluster. And not only a single copy, but 3 copies of each block are distributed all along the cluster. So it's fault tolerant in the sense that we will see an example. It's tolerant in the sense that if one server within the cluster fails, okay, there will be at least 2 other servers holding a copy of all the blocks that were within the failed server. Okay, well, Hadoop HDFS implements several security mechanisms for authentication and authorization, okay? And well, an important thing is that, well, in the end, despite you have a cluster of machines, okay, a distributed cluster of machines, the name node, well, not the name node, but the Hadoop software, okay, provides you a Unix-like file system view of all the data that is stored in the distributed cluster, in the sense that you don't have to deal with which are the nodes in the cluster that are holding the blocks of this file or this other file, but when you interface the Hadoop software, Hadoop just say, well, this is a file, and if you want to read the file, behind the scenes, I will take all the blocks and I will show you the information for you. A very simple example of how a large file is stored in a Hadoop cluster. Okay, you can find here this large file that is based on 4 blocks. Okay, and here you have 2 racks. Okay, of servers. In this case, servers from 1 to 4. In this case, servers or data nodes from 5 to 8. Okay, and as I have told you, okay, each one of these blocks will be replicated 3 times all along all the data nodes. So, if you remember the piece of paper where you put which kind of books and which number of books were in all the shelves, okay, in this case it is the same. If we have this large file, txt file that we were considering before, okay, we will have this kind of table saying that, well, the number of replicas of each block regarding this file and where each block is replicated. In this case, block number 1 is replicated in data node 1, 2, and 5, number 2 in 3, 5, 8, etc. Okay? If we have another file, okay, we will have different location for each blocks, and even we could have different replication factor for this file. In this case, we could say that this file will have a replication factor 2, and each block will be only replicated twice. Okay. So I promise you that the concept of storing books in the shelf is the same than the concept behind HDFS. So what happened if, for example, this server, this data node fails? This data node was holding block number 3 and block number 2, and in this case, well, first of all, if Hadoop doesn't care about the fail, well, at least we will have this block and this other block replicated in any of the other 7 data nodes. But the good thing is that Hadoop Hadoop, once he detects that a server has failed, okay, since it has the number of blocks that were within this server, okay, what he does is just going to one of the other copies of, in this case, of the block number 3, okay, for example, takes this one and makes another copy of this block in another server. That could save this other copy. And the same for the block number 2. In this case, For example, Hadoop goes to this block and makes a copy into this server. So, as you can see, it is very easy to recover from a failure, okay, on a server, because not only the replication factor works, but Hadoop is continually creating new copies of the blocks in order to maintain the replication factor. Okay. In this case, okay, since we have created another copy of this block number 2 in the data node number 2, we can say Hadoop writes in this table the new location for the third copy of the block number 2, for the block number 3. Okay, and how this HDFS is managed or could be managed? Okay, there are several possibilities. Okay, you have here all the possibilities. Not the most common, but the easiest one is through Hadoop commands. Okay, as I told you, you enter in the cluster at any machine in the cluster, and you can perform several special command line commands. Okay. Related to Hadoop, and you can perform operations, typical Unix operations, such as listing a directory or creating a directory or opening a file and showing the content or changing permissions or ownership and so on. Because most of the typical operations that you have in a Unix shell, you will have them available with these Hadoop commands. Okay, but well, this won't be explained here because the Hadoop deployment that we have at FIWARE Lab doesn't allow users to perform Hadoop commands. In the past, we had another cluster in FIWARE Lab. It was a cluster smaller than the one that we have, and well, it was. Just making a summary, it was a worse cluster than the one that we have now. But one of the things that we didn't like regarding the previous cluster, apart from it was small and so on, was that the users could enter into the cluster nodes and perform this kind of Hadoop commands. Well, the problem was not with the Hadoop commands themselves, but the users. The same that they perform Hadoop commands, they perform any other kind of a command, and they tend to install any other application in our Hadoop cluster that was not related to Hadoop. So with this new cluster that we have currently in FIWARE Lab, well, this possibility is not enabled. What is enabled for the users in FIWARE Lab is using the API, the REST API, okay, that natively HDFS provides. Okay, we will see now several examples, and tomorrow I will do in a particular slot that I have regarding this web HDFS and many other APIs that we have available in FIWARE Lab. Okay, I will do a real demo, but well, we will see here in a couple of slides which kind of operation you can perform with this REST API. Any REST API, okay, this is based in HTTP clients accessing an exposed port in the Hadoop cluster. Okay. And well, finally, there is this other option when managing HDFS that is based in a very beautiful user interface, web user interface in your browser, okay? That behind the scenes just call to this REST API in order to perform the operation and show them into a very nice graphics and so on. But again, this won't be shown because due to multi-tenancy problems not problems, but multi-tenancy requirements that we have in this Hadoop cluster in FIWARE Lab. Okay, this has been disabled again. So the possibility, the only possibility for the users in FIWARE Lab in order to deal or to manage his or her data in FIWARE Lab is by using this REST API. On the other hand, is one of the requirements of FIWARE. No? As you know, FIWARE enablers should provide a REST API in order to deal with it. So, regarding the REST API that I'm talking about, okay, it performs the same that I have told you, that the Hadoop commands provide you Unix-like console or way to deal with the data. In this case, most of these Unix-like operations, such as creating directories, opening files, changing ownership, and so on, okay, they are all available in this REST API. Here you have the full specification for this API, okay? But, basically, the only important thing right now is just, this API relies on the web HDFS schema, so the URLs are built this way. So you put the host and the port of the service in the cluster, and then you start typing web HDFS version 1, the path of the file or directory or you want to use, okay? And the operation. We will see that there are operations for example, list status is the operation that allows you a list in a directory, or open is the operation that allows you to print the content of a file, or mkdir is the operation that allows you to create a directory, and so on, okay? Here you have 3 examples of how this API works. Okay, in this case, we have this URL. Okay, this is not correct. This is particularly this is the old cluster that we have at FIWARE Lab, cosmos.lab.fiware.org. Now we have, we will see it later in this presentation. Now we have 2 clusters, one for storing, another one for computing. So the new URL should start with storage.cosmos.lab.fiware.org. Okay, but well, the rest of the URL is correct. Okay, in this case, we have to interface this 14,000 port. Okay, and we start writing web HDFS version 1, and we start putting the path of the file that in this case we are going to open. Okay, so our file is under this path. The root, okay, and then user FRB, that this is my user, or is my real user in the Hadoop that we have deployed in FIWARE Lab. And then, we could have several direct directories and subdirectories where we have the final file that we want to open. In this case, this file is just a copy of the first page of this Stephen Hawking famous book, okay, A Brief History of Time. So if we open it, okay, we will see the content of the first of this file. Okay. If, for example, we would like to create a folder within this webinar subdirectory within my user space, okay? Well, you receive a JSON telling that we have success when creating this directory, okay? And for example, if we finally want to list the content of another directory, well, you only have to use the operation list status, and the content of the folder is depicted into a JSON format. Okay, so well, as I'm telling you, we will see tomorrow real examples of how this API works. So well, as you can see, you have a very powerful and well, I think very nice way of dealing with your data, of doing input and output of your data against a Hadoop cluster. Okay, as you can see here, there is no details regarding how the data is distributed in the cluster, because in this case the API does everything for you. Okay, so we have seen how to deal with the storing problem in batch processing. Okay, let's go and see how to deal in this case, not with the storing but with computing this data that we have collected and storing in HDFS. And again, in this case, the reference for batch processing is Hadoop and its MapReduce paradigm. Okay. Again, continuing with the example, what happens if you have a lot of books and you don't have the time for reading all the books? Well, you call your friends and you assign a book to all of your friends, and you start reading the books in a distributed way. No? So, well, this is the concept of distributed computing. Just adding more workers, or well, in this case, we will see the tasks are particularly called map and user task, okay, that will run in parallel in a distributed cluster, okay. Well, this kind of parallel processing is the key for processing big large amounts of data. So, well, just making a bit of history, okay. Hadoop was created by this guy, okay, Doug Cutting. He created Hadoop when he was working at Yahoo, okay. This is the logo of Hadoop, and well, why the Hadoop logo has an elephant? Well, the rumors say that he used this doll, this Muppet, okay. This was a doll from her daughter, okay, and well, he decided to use this kind of elephant in the logo just just remembering her daughter. Okay, that's not important. The idea is that that cutting was based on a patent by Google that was particularly called map and reduce. The funny thing in the United States is that you can patent an idea, but anyone can create an implementation of that idea. For example, here in Spain, ideas cannot be patented but you have to create an implementation of your idea in order to have a patent regarding that. But well, in the United States, they are more free than us, and you can patent an idea, and then you can create an implementation of that idea. Here you have the patent number in the United States office, patent office. You can check it for it, okay? Public. And well, as I tell you, well, this guy, that cutting, created Hadoop. Well, not really. Because that cutting just implemented Google, and that cutting just were playing around a very old idea that is divide and conquer, okay? And that's all. Many people, when I make this presentation, they say, after the presentation, they come to me and they say, well, but the ideas behind Hadoop are very simple, and that's true. The ideas are very simple. In this case, the way the data is processed is by following this approach, divide and conquer. So let's see an example. Following again with the libraries examples, well, in this case, Caesar military approach. Okay, we're going to see an example that is about. Well, let's imagine Caesar arriving to Alexandria after the war with Egypt. Okay, and well, he wants to know how much the Latin culture is extended in Egypt, and well, he thinks that the best thing that he can do for knowing this kind of information that he requires, okay, is just by going to the library and processing all the books and well, trying to count how many books are read in the Latin language among all the books in the library of. But the problem is that he arrives to the library, and as in the first or second slide that I have shown you, okay, he sees that well, he realized that there is a lot of books in the library, and by himself he is not able to process all that kind of data. So in this case, Caesar has a big data problem, and what he does is just to apply this divide and conquer idea to this problem. So, well, he has a lot of soldiers after the campaign against Egypt. They are idle and they don't much things to do. So, well, he commands his soldiers in order to process the data. First of all, what Caesar does is to divide the problem into smaller problems. Okay, in this case, we are just depicting 3 soldiers, but you could imagine hundreds of soldiers processing batches of books. Okay, So in this case, this soldier, okay, received this batch of books, this other one soldier received this other batch of books, and finally we have this third soldier, okay. And the only thing that these soldiers have to do is just to take a book from the batch, okay, that has been assigned to him, and just check if the book is written in Latin, and in that case, written in Latin, he only has to go to the last page of the book and see the number of the page, and well, that will be the number of pages that this book has. So once we have seen, this soldier has seen that, in this case, this first book is written in Latin and the number of pages is 45, okay? The only thing that he has to do is just to say to this other guy, okay, guy, I have seen that this book is written in Latin and it has 45 pages. Well, this another guy goes to this stone, okay, and he writes there by using a hammer that there are 45 pages in some book, okay? And the algorithm continues, okay, but in parallel, okay, this other guy takes his first book and, well, he doesn't know if it is written in Latin or so on. Well, he spent this time still reading the first book. And this other one, okay, takes the first book and of his batch, he realized that he's writing in Egypt, so nothing is communicated to this. And well, the algorithm continues, okay, and in the next phase of the algorithm, this takes the second book, and well, it takes his time. He takes his time in order to decide if he's writing in Latin or not. In this case, the second soldier finally has realized that the second book is written in Greek, and nothing is told to this guy. And in this case, the second book for this third soldier again is writing in Egypt, and nothing is communicated to this other guy. And the algorithm continues until all the batches are consumed and all the soldiers in the left becomes idle, and this other one soldier, the only thing that he has to do is just to take all the partial results and perform the final computation. In this case, this is the total number of pages written in Latin among all the books in the Library of Alexandria. And as you have seen, the algorithm is very simple, and these guys have played the role of mappers because all of them have performed a mapping function on the input. In this case, the mapping function is pretty clear defined. You only have to check if the book is written in Latin, and in that case, take the number of pages. And this other guy plays the role of reducer. In this case, we only have a reducer in charge of implementing a reducing task that is take all the partial results and perform the sum of all of them. So these soldiers, okay, have implemented a map and reduce example. And the way Hadoop implements map and reduce is just this, okay? There is no more magic behind that idea. If we want to perform a more complex example, in this case, Cesar not only wants to know which are the number of pages within the books written in Latin, but he wants to know how many pages are writing in all the languages within all the books in the library. Okay, in this case, what the reducer has to provide is not only the number of pages, but they have to provide a tuple, okay, containing the language and the number of pages. This is sent to this reducer. Okay, in this case, there are two reducers, but well, there could be one reducer or three reducers. I can elaborate later more about the number of mappers and number of reducers, but in this case, in this example, we have two reducers. And well, it is assigned that this mapper tells this reducer this tuple, and this reducer just writes in the table that this tuple, okay, Latin and 45. In this case, Egypt 12. Well, this other reducer writes the same in this other stone. And well, the algorithm continues. Okay. In this case, this reducer has a different stone for the books writing in Egyptian, and the books writing in Greek. Okay, but well, you can imagine how the algorithm continues until again all the mappers become idle, and then the reducers know that they have to perform the final sums. And in this case, well, Cesar is able to know the number of pages writing in all the languages. So we have seen two examples of regarding how map and reduce work. Okay. Well, in the real world, okay, how you may write map reduce application. Well, before continuing with this, I told you that I will elaborate a bit more about the number of mappers and reducers. Okay, the number of mappers is always equal to the number of blocks that comprise the data you are going to analyze. For example, if you are going to analyze a directory containing 3 files, and these 3 files contain each of them 1,000 blocks, okay, there will be 3,000 blocks, okay, and then there will be 3,000 mappers. And the number of reducers, there is some kind of hidden magic, from my understanding, but this kind of magic is able to know the number of reducers that the algorithm will need by analyzing the data and discovering if you remember, these tuples that were about the language and the number of pages. Okay, well, this algorithm is able to know that in this particular case, all the languages that will be within the data, and will decide that there will be need three reducers. Anyway, the number of mappers and reducers can be only configured in the sense that if you want less reducers, or if you want less mappers, you can configure that, and Hadoop adapts to that configuration. Not exactly, but he performs some kind of calculation in order to make a trade-off between the optimal number of mappers and reducers and the mappers and reducers you have. But well, being said that, okay, the way you write map reduce applications, okay, is way okay. Mainly, you have to write an application in Java language, okay. Other languages can be used through a functionality of Hadoop that is called Hadoop streaming. Okay, this name is particularly bad chosen from my point of view, because it's not about stream processing, but it's about using other languages when analyzing the data. Well, this program that you have to write mainly in Java, okay, must have these three pieces of code. Okay, you will have a driver that is we could say that this is the main program of the main function of the program. Okay, and this is a piece of software where you will define which will be the inputs, which will be the output directory where the analysis result will be written, and many other things that you can configure. For example, if you want to configure a different number of mapper or reducers, you will put that number here in this driver. And at the same time that you define the driver, you have to define the mapper class. Okay, that all the mappers will implement, and the same for the reducer. You create a Java class with the code with the code all the reducers have to run, and well, all the magic start, because this is really the only thing that you have to provide within your MapReduce application. You have here all the API reference, okay? A very important thing regarding this, and that is not contained within this presentation. This is a mistake from my side. Okay, I will try to fix it and upload the right version to the repository. Okay, is that I'm not telling you here how to run this map and reduce application. Okay. Typically, these map and reduce applications are run through the command line, okay, by typing a command that runs the application. But well, it is not explained here, and that's the reason I've not put a specific slide regarding this topic, because in FIWARE Lab you don't have access to a shell console within the cluster, okay. you are not able to run you are not able to run your Hadoop, your map and reduce applications by typing a command. But as we will see tomorrow in a particular session that I have regarding Web HDFS and another API that is called tdoop. Okay, we will see that this tdoop REST API will allow you to run already uploaded map and reduce programs within the computing cluster. Okay, so we will see tomorrow the details regarding this. Okay, so well, I won't go in. I'm not going to elaborate on these slides because in general we are bad of time. But well, take a look on the presentation. You will see that that our example, our these are going to the Library of Alexandria and so on. Okay, this example will find an implementation regarding it. Okay, in this case, this is the map, the code the mappers must implement. Okay, this is real code that will work if you implement it. Okay, so you can see that it's very easy to specify the code that a mapper has to perform. Okay, this other is the code for the reducer. Okay, the reducer guys, and finally this is the driver, or well, kind of main function where you say well, which your mapper class, which is your reducer class, which are the types of the tuples that are output. Okay, and finally here you have which is the input directory and the output directory for the data. Well, I'm telling you, you have all the details in this slide, and this is real code that you can test. Well, before going to the stream-based computing, okay, just a few words regarding these querying tools within the Hadoop ecosystem. The idea behind these querying tools is that when Hadoop was created, okay, most of the, let's say, data engineers that were working with other tools in the past, okay, most of them were very used to work with SQL languages. And well, they were very used to perform queries such as do a select and then join this select with another one and filter by these fields and so on. You know how SQL works. So people working around the Hadoop ecosystem, well, they thought that something similar could be added to Hadoop. And in this sense, they created several querying tools. In this case, querying tools have a very particular requirement, and it's that all the data within these large HDFS files, okay, these files need to have an internal structure. And what means an internal structure? Okay, this means that they have to be written, for example, in CSV or in JSON, for example. There are many other formats that are supported. And why? Well, we will see later that this kind of internal structure is required because, for example, in the case of if you think in a CSV, okay, you will think in a lot of fields separated by comma, and well, each one of these fields has internally a specific semantic. For example, the first field means this is a timestamp. The second field means this is, for example, this is an entity ID, okay, a context entity ID. Or the third field is the entity type, for example. I'm just introducing how you can use context or Ion context data with these particular tools. So these tools have this particular requirement. Okay, they have to be structured in some extent internally. Okay, and well, here you have the most famous querying tools that appear in the Hadoop ecosystem. We are going to talk only here, just very quick, about Hive. Okay, and its Hive query language. Okay, this Hive query language is pretty similar to SQL languages, in the sense that once you have created, I'm talking in advance, but the idea is that you have a very large data file in your HDFS, okay? And you say, well, I know the data is structured by using CSV or even JSON, okay? And because I know each field in this CSV or in this JSON has an internal meaning or semantics, okay? Sorry? Yeah, but I think we are over time in general. Well, I don't know what people from the organization say. I think I have to start at yeah. Well, I think I have right to go. Well, I don't know. I'm just finishing. What? No, I'm not. I'm not as well. Well, just trying to finish quickly. I don't know what I was telling you. Yes. Let's imagine a very large file in HDFS containing this structured data that has semantic in all the fields. Okay. Well, this data, okay, can be represented as a table. Okay, having a column per each field within this data. So, if we could have this kind of conceptual table, okay, we could perform queries such as, okay, select me this column or this other column, or make joins or make filtering and so on. So in the end, the language, the Hive query language, is pretty similar to SQL. And well, the idea behind Hive is that, okay, we are going to have conceptual tables that are in memory. The real data is not in the table, because the real data is about, for example, a lot of terabytes that doesn't fit into memory. So the Hive table is just a conceptual table that has metadata pointing to the real data that is stored in HDFS. And you may wonder, sorry. You may be wondering, well, if the real data is not in memory but in the files, how you get the data regarding a column, or how you perform selects and joins and so on. Well, the idea is that the Hive behind the scenes performs specific map-reduce operations regarding filtering per column and doing these joins and doing these filterings and so on. Well, you have several examples here in the presentation regarding how you can write these Hive queries, and even how you can use a specific server that will allow you remotely to perform these queries through how to say, a GDBC driver. Okay. So well, just finalizing. Okay. The storm reference, okay. In this case, when you try to perform streaming analysis, okay. Well, the de facto standard is using Storm that was created by this guy at Twitter, okay. And this based again on performing a distribute in this case, real-time computation, okay. You will have topologies of elements, okay. And these elements will be performing each one of them a very basic function. Okay, you have here several examples of what these so-called bolts elements perform. Okay, you have one-to-one operations, n-to-one operations, and one-to-n operations. Okay, you have special nodes that are called spouts that are the ones in charge of getting the data and passing them to the bolts. Okay. And well, this is again scalable and fault tolerant in the sense that well, if you may have several bolts in the same layer, let's say the same layer performing the same operation, and if one of the bolts in the same layer fails, well, you have several other bolts performing the same operation in the layer, so the data can be root. Finally, well, one of the main features of Storm is that it guarantees the data will be processed because they internally perform an acknowledgement mechanism. Okay. And well, finally, how have we implemented or used these technologies in FIWARE Lab? Okay, we have both Cosmos and Sinfonier. Cosmos is just for batch processing, and Sinfonier is for stream processing. Okay. And well, Cosmos is based on Hadoop. It is installed as a global instance in FIWARE Lab, so nothing has to be installed because this is provided as a service, and you only have to request an account on this cluster, and you can start using this technology without installing anything. Okay. As I have told you, you have two different clusters. Okay, one cluster for storage. Okay. This is the name of this storage cluster, okay? And this is the main service that we expose to the users, okay? This web HDFS REST API that will allow you to handle input and output operations. And we have this other cluster that is for computing for purposes, okay? And we mainly have these three services exposed, okay? This TDUP REST API that I have told you that will allow you to run your own map and reduce applications, okay? And we have this Hive server in order to remotely perform your queries to your structured data. And we only have an authentication proxy in order you get an OAuth2 based token, because all these APIs are protected following the FIWARE security mechanisms based on OAuth2. Okay, and finally, more days tomorrow. How you can feed this HDFS deployment that is available at FIWARE Lab? Well, mainly you will have to use this Cygnus tool that we have been talking about all around the sessions, okay? This is the standard connector for NGSI in FIWARE, okay? And well, it provides connector for a wide variety of persistence packets, including HDFS. So by using Cygnus, you will be able, we will see it tomorrow, okay? You will be able to persist your context data handled by Orion into HDFS, these other persistent backends. And regarding Sinfonier, okay, this is something that will be available very soon in FIWARE Lab. Okay, we have developed the code, but we don't have yet this global instance deployed in FIWARE Lab. But the same, this will work as a global instance. You will not have to install anything, because the only thing that you will have to is just to request an account. And this will be providing stream analysis services based on a Storm cluster, okay, that will be running behind the scenes. And again, you will be using Cygnus in order to provide context data to this Storm deployment through Cygnus and some Kafka queues that we put between Cygnus and Storm. And that's all from my side. If you have any question, or even if we have time for questions. But if you have any question, I can answer you, or even I can answer you in petit comité. So as you may want. Okay, thank you.
Hello. We have one remaining session for this sprint. I suppose the coffee break, and two more after. I don't know if people is more willing to get a coffee break right now or attend this talk and make the coffee break after. I promise to be brief. The problem is that maybe we take some time there and we finished today really late, but maybe. Coffee break was from 15 minutes to 5.
Aquí. ¿Me oyes ahora? Hola. Cero nueve cero tres. Y la otra es 0616. Cambia la 0903 y ya está. O lo cambio yo aquí, como quiera. Claro. Sí, ahora te estoy hablando por el micro. Hola, sí. Hola, hola, hola. Habla tú.
Well, let's go on with the remaining talks of today. I'm going to try to link different components we have already seen this day. I'm going to show how to publish context information, how to publish this information available, for example, in Orion Context Broker as open data, and how to evolve it so as to give support to a real economy of data. Well, I will introduce myself. I am Miguel Jiménez. I work at Universidad Politécnica de Madrid, in short UPM, as a researcher and lecturer, and also I am architect of apps chapter. Well, this is my outline. It is the summary of the talk. I'm going to give an introduction of open data, how to take this contextual data, this NGSI-based data to an open data platform, and the next step is to go to an economy of data, how to monetize this data, how to enrich with other data application services in a standard way. Well, let's start with a sentence of someone you may know. You know who Nelly Cruz is, really? She is the former commissioner of a digital agenda in Europe. Her sentence does stress that data is a relevant factor for the new digital era. We go deep into a definition of open data. We do see different concepts really interesting for the data to be considered open. This data must be free to use or free to reuse. This is one of our objectives here. That anyone can reuse that data. Anyone can make business with that data. Anyone can enrich that data, link with other one, generate more interesting data, or make application services for citizens with that data, reusing, redistributing, and adding value. If we go to a deeper analysis of this definition, we can see different attributes that are desired for really getting open data. It must be accessible to anyone. I'm going to refer to an European directive on public sector information. It's quite old, but not yet put in place till the end of last decade, about that anyone, being wide corporation, being a citizen, should be able to open this data considered as open data, so as to anyone has the ability to get it, reuse it, contribute, and make the most of this data. The reused possibilities are then one of the most important things of this data. Of course, the data has to be of quality and has to be updated, and updated in two different meanings. Updated on the sense that it's not outdated, it's not all data, but also updated in the meaning of real-time or near real-time data. The most valuable data is that data that you get exactly in the same moment that it's being produced. And it's a real example of something you have been talked about today. For example, data provided from Internet of Things to this Orion Context Broker through standard APIs of NGSI are this kind of near real-time data. This data is the most important one, or the one that adds more value and is able to provide better services for citizens. And of course, it has to be linkable. The idea here is that anyone, corporations, citizens, anyone can access the data to provide their own ability or their own ideas of how to exploit this data, how to merge with some other data, how to mash up this data with that other one so as to create value for the society. Most of the data is published by some government. It's called public sector information. It's not all the data that has to be all the open data that has to be considered public sector information, but most of the time it is. Of course, it's desired that private sector does provide this data, but it's not a widespread case. Most of it is provided by some government that wants to open the data that the governments have. They do already have this data for us, and they want to distribute it. If we examine open data classification by Tim Berners-Lee, do you know who Tim Berners-Lee is? In this case, it's more famous. Well, this classification by Tim Berners-Lee does give us the clues, or different clues, that what has to be open data. The first level, the 0-star level, is that data is online but not reusable under any open license. If you cannot reuse it, it's not really useful. Next, well, feature will be that has the open license, and the data that has the open license has to be structured so as to be machine readable. The data is not for human eyes, it's for machines, it's for being shared, it's for being composed, it's for being discovered by machines. And so as to be discovered by machines, we need to provide them in open standards, non-proprietary formats. Something that in FIWARE is really well stressed from the very beginning. And more other features, do remember that Tim Berners-Lee is the creator of this classification, is that this data is identified by URI, Universal Results Identifier, and that it's linkable. It's really interesting that data from different sources can be linked, can be merged together so as to create this added value of joining it. There are many data you have to find, you may find as open data, or you can publish as open data. There are many sectors that can benefit from this open data, from agricultural, from transportation, but one of them, or one sector that englobes most of these concepts, are smart cities. Data for smart cities can spread many necessities for the citizens. And why do some cities, some governments want this open data? Because, as we said before, anyone can access to this data. And this is because the people that opens that data want to exploit the talent of everyone. Everyone should be able to discover this data, use this data, reuse this data, and make the most of it. Unlike other services that city governments provide to us, these database services are not compulsory be provided by the governments. The governments must provide the open data and the platform, but the services, the added value, can be provided by citizens themselves. And this is what leads us to the third concept in the presentation, that business ecosystem. If these citizens, these companies, these startups, these big enterprises can monetize their work with the data, can provide better data, and someone can get benefit of that, they will push, they will work on using this data, promoting this data, creating services and creating applications. And that's why not governments are the only ones that have to provide these services. They must provide the platforms for that. Well, do you know SECAN? It's the de facto European platform for open data. It's used in many cities, many countries that have their open data platforms. For example, I remember the UK, which is one of the most active countries in Europe on publishing open data. Their main open data platform is built with SECAN. SECAN is a platform for offering open data that has many plugins. It's extendable in many ways. I'm not going to all of the features of CCAN, but I want to tell you that in FIWARE we have integrated a special instance of CCAN with some modifications so as to it fits really well in FIWARE. It's integrated with the identity manager so as to use your own user in the identity in the IDM created by the security chapter. It has a plugin for creating private datasets, which may seem quite strange. Why do you want private datasets for open data? Because it's the door so as to monetize that data. You make the datasets private, and the business API ecosystem, which is another component I'm going to show you after, is the key so as to manage who can access that data or under which terms that people can access that data on a per usage basis or a subscription or a single payment or simply, and it's really easy but important, under certain terms and conditions, because CCAN does not allow to force the users of the certain data to sign certain terms and conditions, and with FIWARE you can do that. Well, we have been talking today about context data, context information. Let's try to fit this into the open data. As you know, in a smart city, you have plenty of information coming from really heterogeneous sources. Really heterogeneous sources with really heterogeneous information. It can come from Internet of Things, it can come from other data platforms, and it may be complicated so as to create a solution that integrates this data from heterogeneous sources. That's where NGSI standardized APIs implemented in Orion Context Broker, which was one of the first talks today, comes into play. And in CCAN you can deploy open data in NGSI format, so as you can access all of these range, all of these wide possibilities for getting open data or getting data from heterogeneous sources in a single standardized way. So in the second instance we have deployed in FIWARE Lab, or you can deploy your own one, not only traditional static data can be accessed, can be stored, and can be discovered, found, used. Also, all the data coming from the context broker, from Orion Context Broker, that gives access to really a wide range of heterogeneous context source can be used. And moreover, not only you can access that data, it serves as a vehicle for accessing much other generic enabler implementations, much more components inside the FIWARE ecosystem. For example, 3D user interfaces, for example, complex event processing, big data analysis driven by this data visualization, as will be presented in next talk. But this is not the end of the path. It's only a step, more step. We need a way of getting to a real economy of data, because until now we have seen how to publish open data and how to publish open data in standard ways to solve the heterogeneous problem. But we want to monetize that data. And I must say that not only the data has to be monetized, the applications that can be done with that data, the services provided based on that data more data built upon different pieces of data have to be monetized. Even visualizing, as Alvaro will show, can be monetized. I said before this specific point of terms of use. That doesn't mean earning money for the data, but it's important for some governments that want to offer the data, but want they have strong opinion about terms and conditions that users of the data have to sign. So also covered. We do support revenue sharing models, and we are working for multi-partner value chain, so as to have different partners in the offering of the same data, and the same partner acts as purchaser of some data and acts as seller of more data, applications, or services built upon them. And the same platform can handle offers, complex offers made from the end clients to the end data providers, bear in mind all of the elements in this chain. I think more or less all of these features have been talked about. Data is products are stored in catalogs. They are offered as offerings. We do support pricing models, pay-per-use, different models. It supports billing. It supports charging. It can be used for even for API monetizing, because you can download a proxy agent and put it in front of your APIs and account for the different calls, and it automatically takes the information to the business API ecosystem so as to rate it and to share for that. It has integration with PayPal. Tomorrow we'll do a demo. Of course, I will not waste my money and will use a PayPal sandbox, but it really works with real PayPal. And we have this revenue sharing models with multiple stakeholders. But we have not built this alone. We have built this with TM Forum. We have helped with TM Forum standardized APIs for business models. The greatest value here is that business API ecosystem is the first integrated implementation of TM Forum business APIs. I must admit that we have only covered the first bunch of APIs, and the newly recently launched APIs are under development, but we are also working on that. So we do benefit from these standards coming from FIWARE for the API for NGSI, or for the API of the different generic enablers, and also from the TM Forum open APIs that foster the adoption of end-to-end services. These APIs are, are plenty of them. I'm not going into all of them, but I want to say that we have APIs for managing the life cycle of products, for managing catalogs and offerings inside those catalogs related to the products, for managing the orders of those offerings so as to make these products available to the inventory of the clients, and so as to charge the clients, bill for them, transfer the money to the sellers. So we do implement all of the TM Forum APIs for that. This is an overall architecture of a business API ecosystem architecture. these are the different team from APIs, and the main point here is this proxy orchestrator that receives the requests. Of course, it works with the identity manager. Of course, it is integrated into the identity manager in FIWARE, and it does make the different calls to the different APIs implementations. For example, create a new offer, or buy a new offer, or account for the user, or for the usage of different API. If you want more information on this, we will have a more technical talk where we will demonstrate all of these components tomorrow. And of course, we have an entry in the FIWARE catalog, but we can have the technical documentation. You can create your own instance with Docker, but of course there's a global instance in FIWARE Lab, which I think I forgot the URL, is store.fiwarelab.org, and you have several slides in the academy so as to get more details about this. And this is all. I hope having been concise and brief. I don't know if you have some question, please. No, we do not have a reputation model, as I think it's what you question. We do here based on CCAN and CCAN possibilities, but I wouldn't say that CCAN has not this. Maybe there's an extension for that, but I do not know it. Some other question? So I think we can conclude the presentation and go with, sorry. Well, they do already have, or most of them do already have, a CCAN instance for offering the data. But one of the first things we did, it was focus on this, was this about private data sets and forcing them to accept terms and conditions, because it was one of the requirements of many municipalities which want to offer open data, but they want that anyone accessing it signs some terms about what you can or not. But this platform is quite mature, and not all of the functionality has not been long in deployment. We have seen that they like CCAN, but there are several limitations that make it not the best option. This is the not possibility to force a sign of terms and conditions is one small example that CCAN is not standalone, is not the best option for municipalities, and you don't have in CCAN any monetizing capability. So thank you very much for your attention.
Okay. Okay.
Okay, it's working. Okay, I'm Álvaro Arranz, also from UPM, from the Universidad Politécnica de Madrid, and I am the lead developer of the WIRE Cloud, the reference implementation of the application Mass App G. Okay. We have seen that there are a lot of context data, open data. Dashboards are a way for displaying that data in a simple way for having a first, for example, a first version of the data or a first prototype of visualization of that data. And I'm going to show how to create that kind of dashboards using WIRE Cloud. We have also another use for the dashboards are for administrations, admins, panels, and for system for tracking events and so on. So I want to make a brief presentation of WIRE Cloud. So WIRE Cloud, like other dashboards platforms, based on the term on the concept of widget. The widget is the minimal user interface PS that can be used for building a full dashboard. In WIRE Cloud, each widget is isolated, so each widget can use, well, they are based on web technologies, so you have to build them using HTML and CSS, JavaScript, so on. And they are isolated. So if you include some library, it won't affect other widgets. So when you develop some widget, you don't have to worry about if one of the widgets uses a library that is incompatible with one of the libraries you use. So finally, you use several widgets for composing a dashboard. In WIRE Cloud, another of the functionalities that we give is the option of sending events. So the idea is to create interactive dashboards. So the idea is, for example, if we have a chart, we can use the events created by the chart when the user click on some of the lines, on the points of the charts, and that can be used for changing the visualization of the other widgets. Okay, so when you use WIRE Cloud, you create dynamic dashboards. We have said that widgets are built using web technologies. So they can be seen as a client, usually, for example, for making something interesting. They usually access some backend service. For example, if you have a chart, you probably will want to retrieve the data from some sources, a context broker, from CCAN. Well, widgets can do that by himself. But one of the things that WIRE Cloud makes is separate that access by means of using operators. So, for example, you have a chart, and you have an operator for retrieving data for CCAN or from the context broker. The idea is to have one widget, chart, map, that can be used with the wanted operator for retrieving data from the data source. So that is the idea of using operators and pipes. Also, probably we are going to see that sometimes there are services that don't require an API because it's very simple to access that services. But for example, the GSI server, the context broker, notifications are provided using a post request to a server. In case of widgets or a web page, it's very hard to create a web server for retrieving that notifications. So we provide an API for making queries to the context broker and for being able to receive that notification using the proxy. We have also support for the object storage that is not very used today, but yeah. Okay, we are going to see that we have components for using Curento and other GIS from FIWARE, okay, but they don't need an API. So we have a binding for NGSI, and the others generic enablers in general don't require that binding. Not working. Okay, so from the point of view of the developer, WireCloud wants to provide or to simplify the development of dashboards. The idea is to reuse components. So one developers will have to develop a widget or operator that is specific for that use case. Probably we provide some a map widget, a Curento one-to-one video call widget, and so on. But probably if you are going to display some mashup using some particular logic, you will have to develop some components, some widget or some operator. The idea is to have to develop only one of those widgets, not all of the widgets. From the point of view of the end user, we want to provide an easy way to create dashboards. So you will have to have a develop, but he will develop your widget, or in case you have to want to create a simple dashboard, probably it's enough with the catalog of widgets and operators we provide to create some simple visualization. Okay. So in this case, you have to go to the WireCloud editor, drag and drop some widgets, make some changes on the configuration, select the entity you want to show on the map or something like that, and you create the dashboard. So the idea is to make it easy to end users to create a dashboard. Okay, to provide that, WireCloud provides several modules. One is the wiring. The wiring is the mechanism for for sending events, but it's also we have an editing tool that allows you to connect widgets and operators using wires. Because we don't have an automatic connection mechanism within that. For example, if you want to create a visualization with a map and a chart, and you add a SICAN operator and context broker operation, it's very hard to create an automatic mechanism to connect widgets and operators, because you have to select what data you want to see in one of the widgets, and what data you want to see in the other widget. We have also a proxy, a cross-domain proxy. In the case you want to access some service that don't provide, there are some limitations from JavaScript that don't allow you to make a request to other domains if they don't provide access. So there are mechanisms of access control headers. If the servers don't allow you to access, you are not allowed. We have a proxy for allowing that. We have talked about integration with other GIS. One of the GIS have bindings for accessing them, and another we have provided a set of operators and widgets depending on the several things. So, for example, we have widgets for browsing data set stores on a SICAN server. It's a widget because it's a visualization, but we have also an operator for retrieving data from a SICAN source. Others of the GIS, for example, the identity management system is integrated, but not in form of operator of a widget is integrated in the system. You can configure Wildcloud for using the identity management system, so your accounts are the same stored in the IDM. And we have also integration with the business ecosystem for allowing to having a set of widgets operator being published in a server. So the idea is to publish widgets and operators there in the store, and you can get those operators and widgets for being installed in the Wildcloud instance. Some of that can be sold, so you have to buy a widget or operator. For the moment, we have only free widgets and operators. Okay, another thing to take into account is that Wildcloud allowed to share the dashboard. You can share the dashboards with a concrete set of users, groups, sorry. Or you can make the dashboard public, so anyone in internet can access the dashboard. For example, anonymous users. Once you have a dashboard, you have created a dashboard, you can embed it in another page. We are going to see how to do it. Well, I'm not going to make a real demonstration because I only have slides. Tomorrow I'm going to do a more technical presentation that is going to be using a web browser, and we will see Wildcloud in iteration. But for now, we are only going to see the idea. The idea is that you can create a dashboard and you can include that dashboard inside an external web page. For example, in a view of the SICAN portal. Okay. This is the main interface of Wildcloud. In this case, we have only a widget that is a map, and is showing data coming from a context broker server. Okay. As we have said, we have added support a proxy for receiving notifications. A slide, but the idea is that updates in the position of the buses or another attribute of the buses is updated in real time. Well, real time, in more or less real time. Okay. This is the wiring editor view. Okay, so we have, I don't know, yeah. This is one operator and another operator. This operator is the one in charge of retrieving the data from the context broker and sending it to the map. The Santander bus is the title of the widget. Okay, so this is very simple. We only have to add an extra operator for transforming the data to be in the map. Okay. The idea is that here we have a bubble with the information. This operator is generic. If you want to create another visualization of the data from the entity, you have to switch this operator with another that builds another interface for the data. This is a generic operator that reads the entity and writes the key value pairs in a simple manner. You want to provide, for example, is one of the attributes contains an image, you can display that image inside the bubble if you create a custom operator for the data. Okay. This is another example of dashboard, or possible dashboard. This is a administration panel for a WAR Cloud instance, for a Orion server. In this case, is for the global Orion instance. You can see a list of the entities that are available in the context broker. This is a list of the available types in the context broker. This is that there are entities using the Sevilla water type, and those entities use the volume and timestamp attributes. Okay, this is a very simple dashboard in the visualization because it's only a list. But we have another option that have WAR Cloud is to so widgets can create more widgets. For example, we have here a button because this widget can detect when the entities provide a position attribute, and you can see a preview of those entities in a map. We have also support for creating new entities because there is a plus button in the entity list. And another option, WAR Cloud have two basic components, widgets and operators, but also supports the MASAP component. So you can store allow to store a MASAP component that is all the composition that can be used for. In this case, it adds a template because you have to enter the NGSI server URL, the tenant and the service path if you want, and after entering that data, you will have a new dashboard using that context broker. So the idea is you can, once you have build a dashboard, you can create a template for creating new dashboards. This is another dashboard, but it is more or less the same, but is using data coming from CCAN. It's very important. The only thing is we have said that one of the things is to provide dynamic interactive dashboards. So in this case, we have connected the map with the web browser because one of the data coming from one of the attributes coming from CCAN is a URL for the webcam. So you can create this kind of dashboards where you can click on one icon and the other widget can change. This is the wiring in this case because there are three kinds of data. There are the webcams, the kiosk, and panels for the traffic panels. not very important, but we have 3 connections because we want to retrieve data from 3 data. We can also mix data coming from CCAN and from the context broker. So the only thing you have to do is to add the data sources corresponding to the source you want, CCAN or context broker, configure it, and connect them. Okay, and the next thing is we have said that WireCloud allows you to create or public dashboards. If a dashboard is public, anyone in internet can use the URL that is in the address bar to access the dashboard. You can you can set it as private, and you can edit the list of the persons or the people that can access the dashboard. I have missed some slides here, but you can also most of the operators from CCAN and the context broker allows you to tell if you want to use the credentials of the dashboard owner, or you want to use the credentials of the user accessing the dashboard. So you can create a dashboard using your credential, the credentials of the owner of the dashboard. You have paid for the data set. You have paid the data set. And you can use WireCloud to make that data public for visualization, and the users accessing that dashboard don't have to pay for accessing it. You have also the option of creating a dashboard and using the credential of the user. So if the user don't have credential for accessing the data, the access will be forbidden. This is an example of WireCloud being embedded in a page. In this case, this is a CCAN portal. Is the global install of the FIWARE Lab, and you have the idea is to have the visualization assigned with the data set. We have this is a plugin, so you have the option of entering, going to the CCAN server, and you can edit a resource view and create that view using a WireCloud dashboard. You can create that dashboard directly on WireCloud and associating it, or you can use a wizard for simple dashboards. If you create a simple dashboard using this wizard, this will create a dashboard. So you can later add more widgets and provide more value to the visualization. Well, we have also operators and widgets for accessing GitHub, GitLab, and you can create that kind of dashboard for tracking projects, software projects. This is a agile visualization. You have a down chart. You can click on the chart. So if you click in this bar, that means that some developers close 2 tickets. If you click here, the list of tickets that is below will be filtered to show only that tickets. We have more components. We have example components for using Curento for making video calls. There is also an example for the crowd detection plugin of Curento. And for example, there are and there are more panels for monitoring OpenStack instances. This is the FIDAS project. And this is more or less all the samples I have to provide today. If you want to try WireCloud, you have several options. You can use the global install that is available on masa.lab.fiware.org. You can create your own instances, but in FIWARE Lab you have the option to use the image of the blueprint. The image will create a virtual machine directly, and the blueprint is like a template. You can install WireCloud alongside another software. You can also use Docker. The Docker image for WireCloud is in this address. You have docker.com FIWARE. If you want to create a standalone instance, you have to run these sentences, this command. In the Docker Hub page, there are more information about how to install WireCloud using Docker, and you have every configuration that has to be made if you want to change something. Okay, one other thing is that the idea is to share, if you develop some widget or some operator, the idea is to share that, in our case, in the store portal. For example, WireCloud, all the widgets and operators that we have built or developed are on GitHub. If you go, that means that if you have some problem with the widget or the operator, you can create an issue in the issue tracker provided by GitHub. So if you have some problem, you can create a ticket. Or if you want to have another feature that is not available currently, you can create a ticket. This is the link to the issue tracker because, well, official widgets and operators have a GitHub repository associated. You probably don't know where is the address for that repository. You can go to the My Resources view page, and you can click on the issue tracker button. That will open the issue tracker associated with the widget of the operator. For example, if anyone allows a widget on operator and it's not an official widget, probably one of the options is to use another source code manager, for Bitbucket or another. So you can click here for well, all the widgets and operators we provide are organized in the store in the WireCloud component catalog, and in the WireCloud starter kit are bundles for all the widgets and operators. So if you install the Orion starter kit, you will install 6 widgets and operators. Okay. The individual widgets and operators are available in the WireCloud component. More information. Well, we have, as always, a catalog entry for the WireCloud the application massage generic enabler WireCloud is the reference implementation. You have the user's manual, the user installations, administration, and programmer guide on ReadTheDoc. We have also lessons on FIWARE Academy that can be used for developing new widgets and operators. Also, I have written here the next talk about the dashboards that will be held tomorrow this time frame. And if you want to make any technical question about Wire Cloud, you can use Stack Overflow. You have only to use the FIWARE dash Wire Cloud tag. You can also add the FIWARE tag that is used for the general FIWARE question, and you can search the current questions. More or less, this is everything about Wire Cloud. I don't know if you want to make any question. So I have finished.
Well, sorry for the delay because I was in. We started with the last session of today. I hope that you have enough power, enough strength to this discussion. This is a very hard presentation. I mean that we give you at least the first steps to go into the FIWARE lab, but you can download. If you don't have the presentation, give me your emails and I send you. Today or tomorrow I put a link in order that you can download. Don't worry about that. The idea is that I want to give to you is we have a specific infrastructure distributed around the world now that gives you the possibility to deploy your own virtual machines without any cost. We have the possibility, or you have the possibility to extend the period of time, mainly depending on the business that you have, but at the moment we have several types of users. I talk about it in the presentation, but the more important thing that you have to keep in mind is this is free. You can register and you can use the object storage, the virtual machine capacities that we provide for you, and so on. Okay, I forget to present myself. My name is Fernando Lopez. Currently, I am working in Telefónica. I am a technical expert, and I am involved both in the cloud chapters, like cloud architect, and the FIWARE Ops operation. A set of tools to help infrastructure owners to provide support to the users. I give you some details about the OpenStack. maybe a little one because I don't give you more details. I present what is the more important functionalities that we had. I hope that this list of functionalities will be extended in the future, for sure. I think that I don't have time, but in the presentation, if you go into the FIWARE Lab portals, you can get more details about the extended functionalities. Keep in mind that not the extended functionalities you can apply for them. You need to be community users. Wow. So this is something that you have in the presentation, but maybe you don't have the possibility to use, like trial users. And for sure, reference information, where you can get more details, you can get more emails. And previously to start, I don't show in the presentation, but I put my email of my company, Telefonica, but I moved to the FIWARE Foundation the next month, so I changed my email. But I hope that during the period of time I can maintain the previous emails. Anyway, this presentation, like the rest that I have, I put in Slicer, so when I put the link, tomorrow maybe, you can go there and download this presentation. Well, OpenStack. How many of you work or knows OpenStack? Really? Good. Well, this is at the beginning of the FIWARE, we started to evaluate the different open source solutions from OpenStack, from cloud, sorry. We take, I think, the good decision to work with OpenStack from the beginning, because the community of OpenStack is more proactive than the other one and is more extensive. As you can see here, this is the core service. OpenStack provides store services, networking services, and compute services. They give you the possibility to deploy your virtual machine, to configure your networks, because you giving the possibility to isolate your virtual machine, your data, and so on. What we provide in FIWARE, the FIWARE ecosystem? Well, this is the solution that currently is provided by the FIWARE. We give a specific portal, we give the platform as a service and some tools to deploy your own software in the Chef and Puppet, and monitoring and account services. Well, this is something that will be changed in the future, because our idea is to be totally aligned with the community. So the cloud portal will be the same portal that we have in the OpenStack, making some change in the style side. Monitoring is the same solution that we have in the community, because we contribute to the community in that part. So it's the same. This is the different service that is provided by the FIWARE Lab. The account is I don't know if how many of you was in the previous session talking about the Keystone or identity management, maybe, no? Identity management is the security core components to provide identity to the user of the FIWARE. User to the FIWARE, sorry. And this is integrated also with the OpenStack. We have the compute. This is a component that provides you virtual machine capabilities. Network allows you to isolate your virtual machine or your resource, in that case. Storage, if you want to provide volume for your virtual machine, permanent storage, and also the possibility to deploy object storage. Image, this is a service that gives a management of the different images that are using the OpenStack. The monitoring component, This is based on the Ceilometer service and provide information about the resource that you are consuming, the different IPs that you are using, and so on. And the SDC and Pass Manager are the services that we are using to deploy, to configure and deploy, install, so on, software that you can use. For example, Tomcat, Spark, MySQL, Java. This is not well. This is Europe. What you can see here, no? This is the starting point of the extension of the FIWARE. Because, how do you know, is FIWARE starting in Europe. This is the first subset of nodes, but this is not the current situation. The current situation is we are moving outside of Europe. We have several nodes, 2 nodes in Brazil. We have 1 node in Mexico, very big one, federated. We started with United States. They have at least 1 node, but not federated. We have several other nodes in Europe, in Netherlands, but not federated. Well, and it's growing up and growing up. This is a very important tool that we are using to check the sanity status of the different nodes that we have currently federated, and gives you details about what is the node that we have, if we have any problems, and if we click on them, we can see what is the problem that we have detected. If you are using Amazon Web Services, Amazon Web Services have health, I think, health status or something like that, which you can see the different services of Amazon, if they are running, or so. It's similar to that. Well, the first topic, I will go a little fast. In that case, is the account part. This is provided by the identity management. You have the possibility to create your own user, and you have the possibility to single sign-on with the rest of the part of the FIWARE, like data, like mass apps, and so on. I hope that you see in the previous session. And the creation of the users is something like that. I hope that you see it, no? Okay, perfect. I can move to the next. I don't know if you see it. It's important here because the different type of users depend on the different type of resource that you have. When you create a user, you have the possibility to be basic. You don't have access to the cloud resource. Trial, you have access to them, but with a limit period of time. Basically, at the beginning, 2 weeks, but the more important thing is the number of the users. We have actually, well, currently we have less than 700 trial users. When we reach this number, we started to delete. Of course, the deletion of resource is communicated to the users in order to give you the possibility to recover the information that you have. I mean that when we activate the deletion of resource in the trial users, means that for a period of time, you don't have the possibility to create again. But after that, you have the possibility to create again another account. It's for sanity or cleaning of the resource. But if you have enough if we have enough number of resources, I mean, less than 700, you can create another account after that. Community users is coming from the accelerator program. They don't have any limitation of resource. They don't have, well, they don't have time limitation. And the idea is provide enough resource that they need to create your own company, your own business. The only thing is that you have to provide details about what do you want to use in your business, describe and specify which node do you want to use and which resource do you need, because we have to configure your quotas. Trial user only have 3 virtual machines, 1 IP address, but imagine that you want to create your own business, your own company, and for starting point you need 5 virtual machines with 3 IP addresses. Okay, you specify this number, you describe why do you need this resource, and when we analyze your request, we update your accounts and give these resources. This is the place in which you can create or you can upgrade your account from trial to community. Currently, the community accounts have a period of time of 1 year, but it could be upgraded. If you request to upgrade your community accounts because your company is not finished to go into the market or whatever, you can increase the time. Keep in mind that FIWARE Lab is an open source environment, which means that you cannot get money if you are here. So if you started to create your business here, perfect. You can grow up, you can develop your solutions, but when you started to earn money, you have to move outside of the FIWARE Lab. You have to move to the commercial nodes that we have in the FIWARE, or you have to move to other cloud providers if you want. This is something that you have to evaluate. The only thing that you have to keep in mind is that going here, you cannot earn money, because this is our request. Sorry. This is the form that you see when you try to upgrade. You need to provide the full name, your account email, if you are registered in the FIWARE Lab, what is the name of your company, exactly, the resource that you need, if you came from an accelerator programs or not. Well, going to details of the compute services. I try to show you what is the different steps that you have to follow to deploy your own virtual machine in the FIWARE Lab. This is a list of the different steps that you have to follow, but we saw in detail. This is the cloud FIWARE cloud portal when you are registered. Use my testing user. You can see here the name of your user. Important here is the project that you have managed. Is more or less is the name of the user followed by a space followed by the cloud. And one important here is this. I think that I saw in the next slide. But info shows you the credentials that you have in the FIWARE Lab. This is important information because if you want to use by your own the APIs of the OpenStack services, or if you want to go locally and work locally with the FIWARE Lab, you need this file. You have the possibility to download it, you have to use. This is an export file. The only thing that we don't provide here is your password. We provide the rest of the information except the password. You have to write it. Well, what is the first thing that you have to do in the OpenStack or in the FIWARE Lab, in that case? You need to create the key pair. Why? Because it's the only access to the virtual machine. You cannot go into a virtual machine using user and password. You need to go into the virtual machine using a specific key pair. Okay? This is very important, don't forget it. Why is so important? Because when you create the password, the key pair, this is the last thing that you have to do is click on them in order to download it. Okay? This file is the important things that you have to keep in your local machine. You have to change the permission of this file in order to work with OpenStack, and so on. And the access is only using it. The users that you have to use is for Ubuntu image, Ubuntu, for the CentOS, CentOS, Debian, Debian. But always specify the key pair. Well, if you are using the Windows environments, it's very important that you have to keep in mind that when you download the key pairs, this is a different format that you have with these tools. So it's important that you change the format of the key pair. This is the description that they have in these slides, and the way in which you can go to the put in that case in order to specify the key pair that you have to use. Important things, because if you don't do it, you will see an error. You have to reduce the permission of the files, because if you give a lot of permission, because when you download the file, maybe you have permission from read, write, and execute the private pen files. This is not allowed. You have to reduce the permission. This is a possibility to create your own key pair and import into the FIWARE lab. And this is the way that you can generate this key. Just like the previous session slides, you have the information here, and the only thing that you have to put is to put your key in the public key text and the name of the key pair that you want to use. Well, we have created the key pairs. The second important thing is the security groups. Why? Because OpenStack, by default, have all the ports closed. So if you want to work, for example, with SSH, if you want to access to the virtual machine, you need to open the 22 port. If you are working with Tomcat, you need to open the port from Tomcat. It's exactly the same if you are using MySQL. You need to open the port from MySQL. Don't forget it, because if you don't specify a specific security groups and open specifically the port, you cannot access the virtual machine. The same if you are trying to use the ping. If you don't open the ICMP protocol, here you cannot make a ping virtual machine. You don't get any response. Important, I don't mention previously, but for your maintenance, always provide description from your resources, because after several months, you don't have any idea only with the name. It's better if you provide some description. Well, we have the security groups created, so the next step is to open specifically the port. You have the possibility to specify here what is the IP protocol, TCP, UDP, or ICMP, for example. You have the possibility to define from one port to another port. It's a range of ports that you want to open, only one, like this one. And also, you have the possibility to define a CADR from the upcoming request. Do you know what is CADR? No. Well, it's like a firewall. You are making permission or not to access to your machine. I write, like in this case, 0.0.0.0/0 means that you allow all the IPs accessing your virtual machine. But you can specify here a specific groups of IPs that can access your virtual machine. I think that I explain next slides how CEDR, because when you define your own networks, you have to use also CEDR. But keep in mind that CEDR is defining a set of IPs that you can use. Very simple. Well, if you go into image here, you see not only the global instance that you have, the global the generic enabler that you have in the FIWARE, but also you have the possibility to use the base image. This is the only image that we have allowed to use in the FIWARE lab. Why? Because this image we are every month or every time to time we are updating for security reasons. We have reduced the level of access of this virtual machine, this image, sorry, in order to provide security. So this is the only image that you can use. Of course, maybe some regions are using their own image, but maybe it's not the template image, because they don't, or they provide by itself the security monitoring of the virtual machine or whatever. But this is the image taking into account that we are compliant with the United States security configuration of the virtual machine. So, the creation of one virtual machine is easy. You only have to take one of the base image, or if you want to take a new virtual machine based on generic enabler, you click on them, and you will see something like that, in which the important thing is that section. This is the quotas that you have. And here is the flavor detail is the configuration that you are putting here from your virtual machine. If I could remember, trial users only have 3 available virtual machines here, virtual CPUs maybe 12, not sure. IP address you don't see here, but you only have 1 for trial users. In memory, I think that this is the common. Again, if you are a community user, you have more resources. If you need more resources, you can request us to increase your capacity. Second steps, you have to specify what is the key pair that you have, you want to provide, and also the security groups. Next one is the network. If you are a trial user, you don't have the possibility to define your own network. So you have here a list of networks that you can use. In case of Spain, because this is testing in Spain, this presentation, we have 3 different networks. Why we have 3 different networks? Well, this is the common networks, IPv4. This is IPv6 network, IPv4, IPv6 network. You can use it. You obtain an IPv6 address for your virtual machine. This is a specific network that are used for testing internally. But when you deploy it, if I could remember exactly, provide a private IP address, so it's not going outside of the environment. The best option is to take this one or this one if you want to go to IPv6. Well, This is something that I recommend hardly don't touch if you don't have any idea about that. This is something that we inject in the creation of the virtual machine in order to configure the virtual machine. For example, if you want to play with it, one of the important things that you should change in your virtual machine is the host. I mean, typical problem is when you try to make an apt-get update, or you want to apt install something, you will see that error message because they don't find the host name. This is due to that the host file don't have the description of the host name. So you can put here the information in order to update the host file and incorporate the host name. For example, if you want to play. And finally, you will see a summary of the operation. Important. If you forget something here related to the key pair, related to the security group, or we detect that you are not open a specific port like the 22, we show here a message in order to say you, okay, remember that you forget to do that. Please go back and fill in. Okay, the next steps. We launch the virtual machine. Hopefully, if you don't have any error, that's usually you don't have, you will see this message. The virtual machine was created successfully. And this is the information of the image that I have created, the virtual machine that I have created. The important things here, well, you have here the IP address. This is an internal IP address. You try to access to this IP address is impossible. The second important here is the region. This is a metadata that we put in the information of the virtual machine in order that we can recopilate information from the users, from the use of the different generic enabler or the use of the different image. What is the image that we are using? And one important thing is here. You have the possibility to check if you want to install Java, MySQL, or whatever in this instance. This is the SDC component that I mentioned in the extended functionalities. Well, like I mentioned, I have deployed a virtual machine with an IP address that is not public. So the next steps is allocate a public IP address and connect the public and private IP addresses in order to access to the virtual machine. The first step is I need to allocate a new public IP. So the option here is if you go into details, at least almost all of them have this name, a public external network 01. This is the public network that we have in the FIWARE lab. Almost all the nodes have this name. Maybe change the 01 by 02 or whatever, but public XNet is the maintained. They have some other networks, not related here, but in Spain you can check and you can see Federate External Network 01. This is a specific network that provides you a private IP address connected to the federation, to the rest of the node. This is used by internal service, but you cannot access outside of the FIWARE lab. So I don't recommend to use it. If you want, you can check, but you don't have access from outside. An important here, the floating IP. I make, this is not common because due to that I am master of the node, I put 3 IP addresses because the presentation of tomorrow, I need 3 IP addresses to work with Spark. So usually, trial user only have 1 IP address here. Well, this is something that after some times you obtain an IP address, public IP address, this one. And the next operation is connect this public IP address with the private one. So I had to associate the IP. So you will see something like that. And the only thing that you have to do is from this one, select what is the virtual machine that you want to connect. And then, after some seconds, you will see something like that. The instance test is connected with this public IP to the private one, and you can go ahead. You can check, going into details. How I mentioned previously, the first step that you need to do is reduce the permission of the file. Well, I put here 400. You can put 600 also. It's work. 400 is less resources, less permission. Important. This is a Ubuntu image, so the user that you have to use is Ubuntu. But always provide the keeper. And you go into details, you will see this is the common Ubuntu, whatever you want, and so on. This is a message that we show for all images, and so on. We are working now to make the template, the security template, from the last version of Ubuntu. Sorry, 16.04. But this is in this month or at the beginning of January. We provide the next version of the Ubuntu in the same line that the next image. Well, we see that we deploy a virtual machine, how connect to the external network, and so on. Important things here, and don't forget it. This is ephemeral. Okay? What I mean if for one reason you lose your virtual machine, the data that you have in the virtual machine is lost. I mean, this is a typical error when you are working with cloud. If you don't provide permanent storage for your virtual machine, the data that you have in the virtual machine can be lost. Do you understand it? No. This is a virtual machine is a file. If for any problems that you have in the virtual machine or any problem that we have in the OpenStack, this file can be corrupted. So if you have the data inside this file and the file is corrupted, you cannot recover them. What is the solution in the cloud environments for this problem? The solution is provide permanent storage using volume. In order that you can mount a specific volume of your virtual machine and all the data that you want to store, you store directly in the volume, not in the virtual machine. Why? Because it's totally separated. If you destroy the virtual machine and create another one, you can mount the volume that you have in the previous virtual machine, and the data is there. Okay? You have the possibility to test it because it's very funny. Create a virtual machine, create a volume, mount the volume, make some modification, touch a file, destroy the virtual machine, create a new one, mount the previous volume, and you will see the file there. Okay? Well, why are we talking about that? Because this service, Cinder, is in case of creating volumes and working with them. We will see how to create volumes and how to connect to the virtual machine, access, mount, etc. Like the previous one, you need to give a specific name, provide a description, and say what is the size that you want to provide for this volume. For the demo, I put only 1 gigabyte, but don't worry about that because you can increase this. Important things here. Volume, like object storage, is stored in a specific, in case of Spain, I think that is the same for the rest of the nodes, is put in a specific hardware, as it's replicated and so on. So one important thing of this volume system and object storage system is, for default, the hardware is replicated. So it's very not well. If we have a disaster, a big disaster, you can lose the data. But for the maintenance, you have to be sure that this information don't be lost. Well, you created the volume, and the next step is to attach this volume to a virtual machine. Well, in that case, you have to specify the name of the virtual machine that you want and the place in which you want to mount this volume. And after some seconds, you will see the name of the volume, the description that you put here. I put a volume, the size, status is in use, and attachment. Why you see here attachments in plural? Because you have the possibility to attach one volume to different virtual machines. I mean, keep in mind that you want to make a service in which you have 3 virtual machines behind a edge proxy, and you want to replicate them and make the writing to a specific place and so on. Put this configuration. Well, but it's not all that you want to do. You have a virtual machine that is connected to your a volume that is connected to a virtual machine, but if you go into the virtual machines, the volume is not there. Why? Because you need to configure the volume. This is the steps. The first thing is you need to see the list of the device that you have, and you see, okay, I need to create a valid partition for this file and mount. What is the next steps? Okay. Try to create the partition for this file. Well, the partition is you can do with this command. You have to specify new partition. You have to make M for help. N means new partition. I make a primary partition. I give the value by default, and then write the configuration to the file, and so on. Well, I create the partition. The next steps, I need to format the partition. For example, in that case, I put the Windows format of the volume, and then make the configuration, blah, 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 and this is finished. What we need to do now? Mount the volume. Okay? Say in which place that you want to mount this volume, and this is all. Keep in mind that if you want to switch off, switch on your virtual machine, you should do it again. But you have the possibility to define in this file that when you start the virtual machine, you want that this volume has to be attached automatically. This is something that you do with this sentence. So if you go to the directory in which you have the volume, you will see something like that. I create a file, it's touch me, in order that you can see it. Now, if you want to test, you can destroy the virtual machine, create another one, and not format, and not making the format operation because you lose the data, but you have to mount the data. Only this step, this one. You can make into the new virtual machine, creating a new directory, and mount the directory, the volume in this virtual machine, and you can see that the file is there. Any question? Because this is inside your virtual machine. It's possible that you make it, but sorry. You go to this one. Could be possible, yes. Injecting the data, but it's not at the moment. It's not covering. I take the discussion, but should be possible for sure that you inject in the virtual machine and make automatically the configuration of the volume. But I have to check because the next version of OpenStack, I think that's not. Of course, but I give the possibility that you land it. No, I understand. This is something that can be do automatically. You don't need to do that, but actually it's not provided by the OpenStack. Could be. It's a functionality that we can cover. In fact, the presentation that we have tomorrow, in which I had to do a lot of things, I make automatically. And you can use the same here. Any other question? Okay, we can move to the last important thing and we can finish. We extended a lot. The last one in the core services is the object storage. This is one important component. You have the possibility to store here files, image, very long files, and so on. You keep in the cloud. This is one of the applications that we saw in the past, the different hackathons, different accelerators program. They use this specific component. Keep in mind that we are using here the Cloud Portal, but Cloud Portal is only a web service, web portal that call APIs. I mean, all this operation can be done by APIs. You can go to the Swift component and taking into account the credentials that you have, you can upload, download, etc., any object in your object storage. Okay? Well, the management of the object storage is as simple as possible. You have to create a container, it's like a folder, and you have the possibility to upload or download a file from or to this folder. It's very easy. In that case, well, I have a logo for Malaga. There is to upload this and download in order that you can see it, but I don't have my laptop, so you cannot go directly to the sea. But the idea is you can go there, put image, put files, big files, so on, download or unload. Important things, the same. Swift is a replication services. So the information that you have stored in the object storage by default is replicated by software. You move to the hardware. In case of Spain, we are also replication in the hardware level. In case of the other nodes, I don't know, but it will be the same. Sorry. So the next, extended functionalities. I don't know if you want to go into details or you prefer to stop here. What do you think? You want to go ahead? No answer. Well, I reached the number 57. I give you any other information. From here to the end is another 57, more or less. Anyway, important, let me show you an important thing. Let me, la, 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 la. This slides. Information about the documentation of the cloud portal, you can go here. Documentation of the cloud infrastructure that we have, the identity management tool, the SDC pass, the e-learning platform in which we have several videos, tutorials in order that you can use the FIWARE lab. You know what? Well, this is the slides, the more important slides of my presentation. If you have any problems with your resources, with your infrastructure or whatever, you have the option to send a specific emails to this one, specifying, I need that you provide me what is the ID of your virtual machine, or in that case, the ID of the resource in which you have problems, what is your users, and give me details about what is the problem, or me, or the supporting that is behind. Other important thing is this link. Is if you go to the Stack Overflow, you have the possibility to check the different questions that other users have requested. This is information that could be useful for you also. But if you have any specific question also, you have to put in the Stack Overflow, and we provide answer periodically. This is the last slide. Thank you. Don't forget to send me an email if you have any question. Let me, well, if I move to the beginning, I don't know if I have the option to faster one. Very nice resume. Summary. Well, important. This is my email from now until the end of the year. If you want to follow me, my new email will be fernando.lopez@fiware.org. Okay? And you can, if you want, you can follow me by Twitter, because if we detect problems in the infrastructure, we publish it in the Twitter. Also, we publish that we resolve the problem. Okay? This is something that if you want to keep informed about any problem that we have detected in the infrastructure, this is the place. You can follow me or you can follow FIWARE. But it's the same. You follow FIWARE, I put in the FIWARE, but I am writing. Any other question? It's enough. It's enough.